right, question 3. We got roller coasters. So this one says a roller coaster. It has a mass of 512 kilograms when fully loaded with passengers and kitty cats. The path of the coaster from its initial point, shown in the figure, to point B, okay, so on the bottom up to the top, involves only up and down motion, right? So there is no left to right. This is a nice vertical climb, as seen by the riders. No motion left to right. Part A. If the vehicle has a speed, so the coaster car up here, has a speed of 19.4 meters per second at point A, so at the bottom, okay, what is the force exerted by the track on the car at this point? Okay. So it comes down, it's going to come down this hill, and it hits this lower point, point A, with this radius 1. Okay. We're going to assume radius 1 is 10 meters. We'll assume radius 2 is 15 meters. Okay. So let's look at this one here. So if the car is at the bottom, it is going to feel, of course, the force of gravity pulling down. And the normal force here is exactly what it's asking for. It's the track pushing back up onto the car. It's the force exerted by the track on the car. Okay. So here we have everything just in the y direction. So let's do our sum of the forces in the y. And we look at this and we go, okay, at the bottom part of A, is there any... they are moving in the x direction. They're coming this way, but there's no acceleration in the x direction. We're looking at only in the up and down motion. So we're looking at just the y, just the up and down. And we say, okay, is there acceleration? And well, yes, it is, because this is part of a circle. It's going to have some centripetal force. So mv squared over r. Okay. So non-traditional circle, but you can see that that curved part of the track makes up that circle. So we'll have some overall acceleration, mv squared over r. And then we'll look at our two forces. We'll have the normal force minus gravitational force, and this is not zero, so we cannot state that the normal force is simply just the gravitational force. It's actually going to have a little bit more, mv squared over r, and then we're going to add fg to the other side. Okay. So the normal force here would be mv squared, so m, 512, times v squared. V is 19.4. And that has to be squared. Divided by the radius. The radius at point A is r1, so this is 10. And now we've added fg to the other side, so plus fg is equal to mg. And mg would be 512 times 9.8. Okay. So now that's just a number. Go ahead, let's plug into our calculator and see if we are right. 512 times 19.4, whoops, times 19.4 squared. Divide that by 10. Sorry, problem with the calculator there. And then we need to add 512 times 9.8. And we should get 24,287. And this is just rounded, 24,300, so it's just a rounding up. Actual answer, 24,287. You can round up if you want. That's no big deal. Part B to this. What is the maximum speed the vehicle can have at point B and still remain on the track? Okay, so point B is all the way at the top. Maximum point where it can still remain on the track. So remaining on the track means that there must be a normal force. The track must still be exerting a force on the car, because if it is no longer exerting a force on the car, it means that they're no longer touching. And if they're no longer touching, then it is no longer remaining on the track. Assume the roller coaster tracks at point A and B are parts of vertical circles. Okay, so I've given you R2 now because we're in part B. Okay, so coming down, we're going to draw another free body diagram. This time we're at the top of the circle. We have an FG. We have an FN as normal, just like over at part A. Okay, and we're going to go ahead and sum up all of our forces. Now, just like part A, we're in centripetal motion, but being at the top of the track, this centripetal force points down. So I'm going to have negative mv squared over r. That then was equal to these two forces. So we're going to have Fn minus Fg. Okay. Now, in order for this to remain on the track, I want that to go to 0. I want it to just barely, well, or 0, where it doesn't exert any force anymore. Okay. That's what I'm trying to find, is the 0 point. So if I plug things in, I'm going to have a negative 512. V squared is actually what we're looking for now. What is the maximum speed? So V is what we're looking for. R would be R2 now, since it's the top. So R2 is 15. Okay. And that's equal to, if the normal force is equal to 0, forget it, we can just say 0 minus mg. So m again is 512. And this is times 9.8. Okay. So we got a negative 512 here and a negative 512 here. We can cancel those out. Doesn't matter anymore, the mass. We'll have v squared over 15 is equal to 9.8. So to figure out v, we'll just take the square root of 15 times 9.8. Hopefully that works on your math there. And let's take a peek at that. 15 times 9.8 means that the v max is 12.124. We can just leave it as 1. Okay, and that's how we get our answer for that.